This is Algebra 1, Lesson 8E, Areas of Parallelograms and Trapezoids. It includes examples 8-9 and 8-10. Example 8-9, find the area of this parallelogram. Dimensions are in centimeters. Now there's a formula for how to find the area of a parallelogram, but your book chooses to show you how to divide it into shapes you already know. And their reasoning is that if you have to memorize multiple formulas, it can get confusing. So it's easier if you know the basic formulas and then divide the shapes into those. If you're interested, you can do some research and find the formula for the area of a parallelogram and try it out and see how it compares. Now, if we draw a line to connect those vertices, we have now split this parallelogram up into two triangles, and the area of the parallelogram would equal the sum of the areas of the two triangles. So we have this triangle up here, and then we have the white one that I have not colored or shaded on the bottom. Okay, so let's deal with the bottom one first. We can see that we have a base of 8. Area is going to equal base times height divided by 2. And we see that our base is 8. Now what is our height? Is it this 5? No, it's slanted, right? We need a height that's perpendicular to the base that we're using. So that would be 4. And then we're going to divide that by 2. 8 times 4 is 32. And then divided by 2 is 16. And these are in centimeters. So that was 8 centimeters times 4 centimeters. So we're going to have centimeters squared. Square centimeters. That's the area of this white one right here. Now the other one is going to be exactly the same thing because you have a base of 8. And if you extend it, well, actually, I guess you could do it, yeah, like this. Extend it here and find this height. It's going to be the same as this height over here. So this 8 times this 4, which would be 32, and then half of it. So since we know they're both the same, we're just going to double that. So we know the area of the entire parallelogram is 32 square centimeters. Let's look at 8-10. This is a trapezoid. Now, we've talked about parallelograms and trapezoids before, but you can see the parallelogram has opposite sides that are parallel. It has 2 pair of parallel sides, but a trapezoid only has 1 pair of parallel sides. This side is parallel to this side. This side is not parallel to this side because if you extend them, they're going to intersect, right? So that's a trapezoid. So let's see, how can we divide this up? Well, we can use a very similar process. We're going to divide it up into triangles. And once again, here's my bluish triangle up here, and then my white triangle down here. Now, are our measurements going to be the same? Well, let's see. Let's take the white one first that's on the bottom. The area is going to be equal to base times height divided by 2. So let's find our base. Let's call that 15, okay? 15. And what would be the height? Well, it has to be perpendicular to the base, so it can't be the 5 because that's slanted. It's going to be the 4. And then we're going to divide that by 2. 15 times 4 is 60, divided by 2 is 30. And again, this is square meters, okay? Let's find the area of the other section, and I'll color this area here to remind us that we're dealing with the blue one. It's also going to be base times height divided by 2, but let's look and see what our base is for the one up here. This base is 9. It's not as long as the base we just used, so we're going to put a 9 in for the base. Its height is going to have to be from the base. So you can see here, if you extended this out and did this, it would be the same height as this 4. Okay, because it's directly across from it, and it's a perpendicular height. And then we would divide that by 2. 9 times 4 is 36, and 36 divided by 2 is 18, and this is square meters. When I add those two together, I get the total area is equal to 48 square meters. And that's how you do parallelograms and trapezoids. You turn them, break them into other shapes.